You need to know this before we get into it. What are the large particle gas pedals? CERN's Hadron Collider, LHC, is basically a massive 17-mile wide ring of extremely strong magnets. It is the most destructive particle smasher, the strongest we've ever built. It is able to almost duplicate the universe's beginning. From its inception, this machine was built to uncover the mysteries of the universe. It may hold the key to even more extensive material discoveries. CERN, founded in 1954, is a leading research center with 23 participating nations. It's a hub where many scientists work together, collaborating and creating. The LHC is the crown jewel of the CERN project, but it's just one component of a massive installation of particle accelerators. Consider it like a racetrack. The LHC produces protons, small particles that go extremely quickly, almost to the speed of light. After that, they collide, which results in energy similar to what was present at the Big Bang. The temperature suddenly soars, much higher than the sun's core. Magnets hold the protons on track, and special coolers maintain the order. The beam crashes into something colder than space. There are 4 spots on the ring: Atlas, CMS, ALICE, and LHCb, which are particle detectors. These examine distinct aspects of particle physics, using massive cameras to record the crashes. Researchers study the leftovers to discover things like the super-rare God particle, or Higgs boson, and additional particles that might show us how the universe is constructed. By closely examining minute details, we learn more about the entire universe. But each time we answer a new question, another test arises. The LHC is proof, not just a scientific tool, but of the extent of human curiosity. Its arrival demonstrates our sincere desire to understand how the dominant forces operate and shape the universe. But what do we push when we explore? We must consider the ethics. What could go wrong? By looking into the unknown, we might unintentionally release something we cannot control. At CERN, they're always putting knowledge to the test. Brian Cox, a scientist who used to work at CERN and is well versed in particle physics, once made a comment that got everyone talking. He said the LHC intends to produce a mini Big Bang, a miniature version of the beginning of everything. Cox also discussed how this could assist us in major discoveries, such as the Higgs boson and dark matter, mysterious elements that comprise the majority of the universe. Imagine being able to fabricate the elements that make up the universe. Sounds cool, but this is extremely risky. A mini Big Bang is more than just an idea. The LHC can actually generate the heat and pressure similar to what existed at the start of the universe. With that much power, we must be responsible. In fact, in 1978, something went wrong. Anatoly Bugorsky, a physicist from Russia, suffered a terrible accident while working. A beam of protons hit a machine and struck him directly in the head, entering from one side and exiting the other. But he survived. He even walked to get help, conscious and able to think. Still, the beam harmed some tissue, causing hearing loss in one ear and facial issues. This demonstrates how potent and perilous these particle accelerators are. We cannot minimize the dangers posed by machines like the LHC. There's always a possibility of causing odd reactions and tampering with the fundamentals of everything. This isn't just sci-fi. Real scientists have expressed concern. One of the LHC's most terrifying possibilities is that it could produce a miniature black hole, something with such high gravity that nothing, not even light, can escape. Even a small one could theoretically be produced by the LHC. This is shocking. It could spiral out of control and consume the Earth's crust. It's believed that any black hole created would be unstable and vanish quickly, but even a small chance of something catastrophic is enough to cause fear and curiosity. To understand how a black hole could be created by the LHC, we need to comprehend the fundamentals. When protons slam into each other almost instantly, they produce immense force, bending space-time. Imagine a trampoline. If you drop something heavy on it, it will bend. If the object is heavy enough, it produces a deep hole that pulls everything nearby in. That's the kind of thing that could happen at the quantum level in the LHC. Some believe there are additional dimensions we can't see, hidden, but accessible under extreme circumstances. The LHC could create a tiny gravitational spot in these dimensions, a black hole. This caught the attention of scientists like Stephen Hawking, who warned that a very high-energy Higgs boson interaction could cause a vacuum decay, potentially not just destroying Earth, but the entire universe. Cosmologist Martin Rees also voiced concerns. In his book about the future, he discussed worst-case scenarios, such as vacuum instability that could ripple through space-time and destroy everything. He admitted this is unlikely, but the stakes are too high to ignore. CERN scientists have rigorously tested theories and taken actions to keep everything safe. Brian Cox said the LHC safety plans are comprehensive. Earth's natural energy levels are higher than what the LHC can produce. Even if the LHC created a black hole, it would be minuscule and unstable, likely vanishing due to a process called Hawking radiation. Still, people fear that the LHC could accidentally release something we can't control. The concept of opening a door to something undesirable has been exaggerated in the media, feeding the fear. But the idea of extra dimensions isn't new. According to string theory, more dimensions may exist, hidden from view but reachable under extreme conditions. The LHC could be the key to unlocking them. Yet, there is no evidence the LHC can open doors to other universes or unleash terrifying consequences. What remains is the mystery, the strange and unknowable. Quantum physics keeps us guessing. So should we be concerned about the LHC and its potential? It's easy to get carried away by fear and media speculation, but the truth is, CERN scientists are aware of the dangers. They've taken every measure to ensure their experiments are safe, observing, testing, and revising. Positive outcomes from this research include better understanding of the cosmos and discovering new particles. While dark matter remains elusive, the LHC showcases humanity's ability to reach the heart of the universe. Like any major scientific advance, there are risks. But we must be careful and respectful. The Large Hadron Collider is the epicenter of cutting-edge science. It is where theory meets real-world experimentation. It helps us answer universe-defining questions, like where mass comes from and what dark matter is. Its safety plans are unparalleled. Still, with every new experiment, there's awe, mystery, and yes, fear. The machine's power is incredible, and the possibilities it unlocks are vast. The LHC continues to redefine physics, exploring unknown territory. When particles collide, they recreate conditions not seen since the Big Bang. These tests are significant, even as they raise concerns. Still, what the LHC has accomplished, such as discovering the Higgs boson and expanding the Standard Model, is profound. It opens the door to innovations that may shape our future. Despite the dangers, the pursuit of knowledge is essential. Science is not always safe, and the LHC is no exception. These experiments test the very boundaries of physics, challenging what we result in concern. Physical scientists like Stephen Hawking, Brian Cox, and Martin Rees have voiced both hope and hesitation, marveling at the immense potential of the LHC while reminding us that power like this demands precision and foresight. Because when you're dealing with the building blocks of reality itself, a single miscalculation isn't just an error, it could shift how we understand space, time, matter, or gravity. Imagine a particle behaving in a way we've never seen before, sparking an entirely new field of theoretical physics. Or worse, disrupting the balance of what we know as stable matter. That's why every single collision inside the LHC is tracked, measured, and scrutinized by hundreds of eyes and thousands of sensors. It's not just about watching particles, it's about catching history in real time. And while many fear the worst-case scenarios, miniature black holes, decay of the vacuum, tears in spacetime, the scientific consensus stands. Nature itself smashes particles together at even greater forces in the upper atmosphere every day. If those collisions were dangerous, we wouldn't even be here. Still, what makes the LHC feel different is intent. It's humans choosing to unlock doors, probe the edges, and peek into the fabric of existence. That's thrilling. That's terrifying. And that's the heart of science. We're no longer standing in or under the stars. We're reaching into them. And perhaps the most profound part? Despite decades of preparation, calculations, and safety checks, we still don't know what we'll find. Dark matter, new dimensions, unknown particles, or answers to questions we haven't yet thought to ask. Because the LHC isn't just a machine, it's a mirror, reflecting back humanity's endless hunger to understand. And that is both our greatest strength and our biggest gamble. Stephen Hawking issued dire warnings regarding what could occur, such as instability in the vacuum. Even though the likelihood of these things is low, the public is energized by the thought of them. Some people are intrigued and scared by the LHC. This is a sign of control-seeking individuals, nature's need to exert control over the forces that run the cosmos. For others, it's a tool for observing reality's fundamental nature. Attempting to learn results in risks. There are ethical issues in all science, issues and dangers that we do not anticipate. What takes place when we have the ability to learn the darkest secrets of the universe? Should we pause and consider whether we are prepared for the possible answers? Beyond the known dangers in science and the LHC's exciting possibilities, the Hadron Collider's existence raises important philosophical questions, questions about the extent and breadth of knowledge. Not only does the LHC force us to reconsider what we know, but also how we know it. Scientific advancement has always driven the limits of human comprehension. However, the LHC operates at a level where data and observation become more abstract. It must be interpreted through extremely intricate mathematical frameworks. Like this, a unique problem arises. When evidence is covered in quantum layers of uncertainty, how can we tell what's real as opposed to theoretical? Furthermore, the LHC emphasizes the increasing degree of collaboration. In the modern age of science, no single nation could build or fund a machine of this magnitude by itself. It is a group accomplishment involving thousands, engineers, technicians, researchers, and students, from all over the world, working toward a common objective. That spirit of international cooperation is something rare and valuable, especially at a time when political strife frequently divides countries. The LHC is more than just a scientific endeavor, it's an emblem of global unity for the benefit of knowledge. Another thing to think about is how the outcomes of the LHC's discoveries may influence other fields of science. For instance, advances in understanding subatomic particles can bleed over into improvements in materials, nanotechnology, chemistry, medicine, and energy science. The fundamental understanding gained from these experiments could result in improved imaging, new or faster computing methods, or even new energy sources. Science has frequently led to unexpected shifts in technology. When researchers first began to investigate quantum mechanics, they were unaware that it would eventually result in microchips and smartphones with excessive data storage capacity. Another marvel is the LHC's output. Each second, the detectors collect data from millions of particle collisions. To explain everything, CERN has been forced to create some of the world's most advanced systems for processing data and algorithms. The requirement for high-volume, high-speed computing even resulted in the development of the World Wide Web. In the present day, CERN's computing infrastructure spans continents, a global supercomputer with enormous capability. This ability to analyze data not only aids physics but also sets the stage for breakthroughs in machine learning and artificial intelligence. Additionally, there is a fascinating cultural angle relative to the LHC because it addresses notions such as dark matter, antimatter, additional dimensions, and the very beginning of the universe. It has fueled creativity in a way that few scientific projects have, frequently appearing in movies, books, television shows, and online lore. This exposure to the media is a double-edged sword. On the one hand, it makes the public enthusiastic about science. On the other, it may propagate false information or continue to fuel narratives based on fear. The fact that individuals are even discussing bosons and quarks at dinner conversations demonstrates how potent the LHC's influence has become. Beyond academic research, the LHC has had an impact. In the meantime, ethical considerations continue to develop. In the event of a global framework for controlling high-energy physics experiments, are there international agreements? We've already seen debates around genetic engineering and nuclear weapons. Some argue that going beyond the quantum level of reality ought to emerge with safeguards. The issue with checks and balances is about more than just catastrophic failure. It also entails responsible stewardship of knowledge. Following a discovery, like a new kind of material state or a way of modifying space's vacuum state, who decides how to use it? At the same time, it's critical to acknowledge the LHC's contribution to education. The facility supports numerous PhD programs, fellowships for research, and internships. It goes beyond simply expanding our knowledge base, it instructs subsequent generations of engineers and scientists. These individuals frequently apply their skills in other industries that drive advancement and innovation. In every way, the LHC's influence extends far beyond the realm of physics, into communications, technology, finance, and electronics, through complex methods for modeling and simulation. The LHC is unique because of its humility in the face of the unknown. In contrast to other areas of science that work with hypotheses and anticipated outcomes, physics recognizes that not all experimental results will be definitive. Numerous LHC discoveries have required years to verify, and continue to be debated. This patient approach is a powerful lesson in today's world, which is increasingly fixated on quick results and instant gratification. And finally, the LHC forces us to ask, why are we trying to decipher the universe? Is it because we can, or because we believe it has meaning for us? Are we driven solely by curiosity, or is there an underlying hope that science can help us answer centuries-old philosophical questions about the meaning of life, or even consciousness? Regardless of whether the LHC ultimately reveals the secrets of dark matter or extra dimensions, its value might come from what it represents: humanity's never-ending quest to discover, to ask, and to understand. It serves as a reminder that most of the time, the biggest leaps start with the tiniest of particles, and that even as we look deep into the fabric of the universe, we are also evaluating ourselves. In exploring the universe through the LHC, we're not merely chasing particles or plotting the trajectory of invisible forces. We are, in essence, confronting the limits of our own perception. The very act of experimentation at this scale demands that we reckon with paradoxes: certainty built on probabilities, presence inferred from absence, and truths discovered through approximations. What does it mean, then, to uncover something so fundamental that it reshapes not only our theories but our very conception of existence? History has shown us that each scientific revolution doesn't just change our tools, it changes us. Copernicus displaced Earth from the center of the cosmos. Newton linked apples to planets. Einstein bent time itself. Now, the LHC pushes us toward understanding realms where time, space, and matter lose their familiar meaning. With every collision inside that 27-kilometer ring beneath the French-Swiss border, we are invited to imagine realities that do not conform to intuition. It humbles us. It reminds us that for all our intelligence, we still walk in shadows when it comes to the universe's ultimate nature. And still, we persist. We build larger detectors, run deeper simulations, train new minds, and ask questions with no promise of answers. Because to be human is to seek. The LHC, like the great observatories, telescopes, and laboratories before it, is the physical embodiment of that search. It is ambition made concrete, imagination given a corridor through which to run. It also stands as a mirror. What we discover out there, in quarks, bosons, or gravitational fields, often reflects what we must confront within. Our fears of the unknown, our desires for control, our awe at beauty, and our need for connection to something greater, they are all stirred by what we learn. Perhaps that is the true legacy of the LHC, not just the science it produces, but the introspection it provokes. The reminder that knowledge is both gift and responsibility. That the pursuit of truth must walk hand in hand with ethics. That the universe does not owe us understanding, but still, we reach for it.